Okay, so this one, the matrix transformation question, x is 1, 2, 0, 1. Now you can do that with the unit square and multiply it all out and see what the image looks like. Or we could recognise that as being that pattern 1K01. Most of you got that it is a shear, although it was spelled slightly differently in one or two cases. But we do have a shear from this one, and we now need to describe what the shear has done. And it's fairly vague about what it asks for in the mark scheme, but there are certain things we have to have in there. I think the easiest way to describe the shear is to talk about what happens to a point on the line y equals 1, or on the line x equals 1 if it's going in the other direction. So this is one that would knock things kind of x-axis invariant, would knock things across to the right. And it's best to talk about the image of a particular point. So let's start with the image of the point 0, 1. And the best description you could give is the image of 0, 1. Well, 0, 1 would move 2 places across, so it would end up as the point 2, 1 instead. Or you could say that the point 1, 1 moves across, and the image of that is 3, 1. I think the best way to do it is to talk about a point on the line y equals 1. What would happen to that if it's moving in that direction? If we start getting into descriptions of scale factors, or how much it's moved, or that kind of thing, you need to be quite specific about what's happened. And scale factor isn't really the right thing to say in terms of a shear. Okay, so that was 2 marks, one for shear and one for an adequate description.
So you can't say like the whole y invariant thing?
Well, you can. I mean, in this case it would be x invariant.
Yeah, obviously.
But you need to give something that indicates what effect the 2 has. So yes, saying x invariant is a good thing to say. But you need to talk about how much the line y equals 1 has moved across. What relevance is the 2? Is that alright? Now this was done really, really badly, and it all hinged upon the very start of the question. And the start of the question is that just like when we did that inverse of a matrix, the inverse of AB, it swaps around, so it's inverse of B times inverse of A. When we do matrix transformations, the order swaps round. So this question says that Z, the transformation represented by Z, is equivalent to the transformation represented by X, followed by another transformation represented by Y. So X followed by Y. But in terms of matrix transformations and multiplication, that means that Z equals YX. Because what you're doing with this is you're pre-multiplying your points, your matrix that you're transforming, by this matrix. So this is X followed by Y in that order. And unfortunately, if you got that the wrong way round, there was very little that you could do with the rest of the question. So that's the key thing. Now we've got a few choices about how we deal with this. We know, remember, the question has given us what X is. And that's quite an important thing, we know what X is. So if we try and rearrange this, we also know what Z is. What we want to do is to think, if we rearrange this slightly, if we post-multiply by the inverse of X, then Z times the inverse of X is YX inverse of X. So in other words, matrix Y is Z times the inverse of X. So that's what we need to try and work out. What is Z times the inverse of X? X was 1201. So its inverse is 1 over 1 minus 0. Change the first 2 round. That didn't make much difference. Change the signs of the others. So that's it. That's the inverse of X. So the matrix Y that we're after is Z, which was this monster, a half, and 2 plus root 3 over 2. it next? Minus root 3 over 2, and finally 1 minus 2 root 3 over 2. That times by 1 minus 2, 0, 1. So that's the matrix multiplication we need to do to find y. If we carry that out, we get half times 1 plus that times 0. So that would be a half. We get half times minus 2, that's minus 1, plus 2 plus root 3 all over 2. Here we got minus that, minus root 3 over 2, plus that times 0, and finally we've got minus minus, so that's root 3 plus 1 minus 2 root 3 over 2, which still looks a bit of a mess, but is about to get a lot nicer, because if we work with that, this is a half, this is just, well, here we've got 2 plus root 3 over 2, so that's 2 over 2 plus root 3 over 2, and 2 over 2 is 1, so we've got minus 1 plus 1 plus root 3 over 2. Here we've got minus root 3 over 2, and here again we've got root 3, and then we've got a minus 2 root 3 over 2 inside that bit there. That's root 3 take away root 3, leaving us with a half. So that is the matrix that we were looking for. That's what y is. That's it. It did say find y, didn't it? In that one, yeah. So there's your final answer for that. Which was reassuringly simple. There's another part to this question. So then the next bit said, describe fully the geometrical transformation represented by y. Here we get the final bit, and I'm just grabbing a formula book. Just going out of the shot. Here we are, I'm back. Right. So in the formula booklet, we recognise that this matrix that we're looking at is the one where the leading diagonal is the same and the other diagonal has a change of sign. So what we get from that, it matches up, remember, with the matrix cos theta minus sine theta, cos theta, and it means that for this transformation cos theta is a half and sine theta is minus root 3 over 2. And we're going to do a lot more trigonometry, but if you work on that a little bit, you would get that if you do cos theta inverse cos of a half, your calculator is going to say 60 degrees. It's also true for minus 60 degrees though. So that gives you 60 degrees, or minus 60 degrees. If you do inverse sine of minus root 3 over 2, your calculator this time genuinely does say minus 60 degrees. It's also true for, what would the next one be? Well, it doesn't, it's true for 300 degrees, it's true for 240 degrees, as the next positive one. But that's, you've got minus 60 satisfies both of these equations. Which means we have a rotation, again, according to what it says here, an anti-clockwise rotation through minus 60 degrees. That's a slightly odd way of phrasing it. Anti-clockwise through minus 60 is clockwise through 60. So what we've got is a clockwise rotation through 60 degrees. And that is that.